Hi, I'm Michael Schurter, Nomad Team Lead, here to talk about a simpler Nomad. For those of you who don't know, HashiCorp Nomad is a container orchestrator like Kubernetes. So why do people choose Nomad over Kubernetes? Well, one of Nomad's core strengths is flexibility. Nomad is flexible in what workloads it can run. Nomad officially supports running on Windows, Mac OS, Linux, but users have deployed Nomad on a variety of other Unix-like operating systems as well. Nomad has built-in support for running Docker images, plain binaries, and virtual machines. Users have added support for a wide range of other runtimes via Nomad's Task Driver Plugins API. Podman, Windows IIS, and WebAssembly are just a few of the other runtimes the community has added. And performance is another of Nomad's top priorities. Nomad supports clusters from 1 node to 10,000 or more. Whether running on bare metal or cloud spot instances, Nomad is designed to seamlessly handle the scale that fits your use case. Nomad aims to simplify cluster management. Performance and flexibility aren't worth pursuing if the system is too difficult to operate. But what does simple mean? Containers are complicated. Raft, optimistically concurrent scheduling, streaming bidirectional RPCs, Nomad contains a multitude of complex technologies. All of the complexity inside Nomad has a purpose: making user workflows simple. Whether it's writing a job spec, using the CLI or API, or using this Consul service mesh, Nomad should offer simple, humane interfaces for these complex operations. Let's see how Nomad's simple scalability and workflows work for a hypothetical startup. Many great ideas start as small side projects or experiments just for fun. You keep missing the bus. Mornings are hard, and who can keep track of time before 6 cups of coffee? Technology to the rescue! A few Python scripts later, and you have a Raspberry Pi turning on a light when you need to leave the house in order to catch your bus. Nomad can be useful for simple apps on a single machine. Perhaps your home computer to begin with. One Python script might be a periodic job that downloads the bus schedule and writes it to a database. Another job might be for reading the database and controlling the light. And a third job could be the database itself. Having the bus light attached directly to your home computer is a hassle though. So you pull an old Raspberry Pi out of your closet, attach it to the light. A Nomad agent can run on the Raspberry Pi, so you can easily redeploy the light control service to the Raspberry Pi through Nomad. Soon, your friends want one, and their friends want one, and before you know it, you have 100 Raspberry Pis with lights spread across town, running a Nomad agent and talking to your computer to act as command and control for the network. It's time to scale and make this a real product from a real company. Your users don't want to miss the bus or be unable to reach the web UI whenever you restart your computer, so you need a highly available cluster. You move to the cloud and run 3 more Nomad servers. With a temporary connection to your home computer, these can be set up with zero downtime, seamlessly migrating from your home server to the cloud. Once the 3 cloud servers are running, your home Nomad server can be safely shut down. Your web UI and periodic schedule pulling job can now run on multiple cloud virtual machines in an auto-scaling group. That means if a VM crashes, a new one will be added and the lost workloads will be seamlessly rescheduled. But what about those existing users? They would have been connected to your home server and now that's shut down. Well, as the new servers were added, existing clients were informed about their addresses so that they can access them directly. All connections over the public internet are protected with mutual TLS, so your edge Raspberry Pis remain securely connected to your back-end Nomad servers. But wait, how does the bus light service on the edge client know how to connect to the back-end database of bus schedules and user preferences in the cloud? Nomad 1.3 introduced native service discovery to solve this problem. Advertise your service with a small stanza in your job specification like this. Your database can specify a public domain name for its service so that your services on the edge can connect directly back to it. Within your cloud cluster, Services will automatically advertise their private IP addresses. That way they make direct connections within your cloud network. But service discovery is always more complicated than just a single service with a single address. As you scale, you may need to add replicated API servers in front of your database. How do you load balance across these replicated API services? The easiest path is to use a cloud load balancer or standalone balancer and proxy every request. The downside here is that it's yet another service to manage and it adds latency to each request. It's another point of failure and another service to manage. Nomad Service Discovery can use Rendezvous Hashing so that when an instance of Service A needs to talk to Service B, not only will the instances of Service A be balanced across instances of Service B, but any given instance of Service A will get the same instance of Service B every time. If an instance of B crashes, only the instances of A connected to it will be rebalanced. And if instances of B are added, only a proportional number of instances of Service A will be rebalanced as well. This is called Rendezvous Hashing or highest random weight hashing. And it's coming soon in a Nomad 1.3 release. And it's available either via configuration templates within your job specification or via the Nomad API directly. With these few lines, Nomad simplifies the complex problem of load balancing services. But wait, we're not done with the complexities of service discovery. How do all those edge services talk to the central API servers again? How do we handle that external traffic? The edge services, as well as your users trying to access the web UI, are all external traffic. How do you route them to your services running on the Nomad clients in the cloud? Coming soon is native Nomad support in Traffic. Traffic is an open source load balancing proxy that will soon have native Nomad service discovery support. You can follow this PR to see when that lands. Run Traffic with Nomad on an autoscaling group, routable from the internet, and let Traffic route the request to internal services from there. There's even a Nomad pack, which is similar to Helm charts, for helping you run traffic in your Nomad cluster. You can use Traffic to set up rule-based routes as well, so that as your startup scales, you can split out APIs into microservices. This is an example of configuring traffic routes for a billing service in its Nomad job specification, but Traffic supports a wide variety of configuration options through these tags. Oh no, but now you have a billing service and paying users. How do you manage secrets? You need to make sure you're handling your database credentials and other secrets safely. Nomad 1.4 will add support for secure variables. Secure variables will be encrypted at rest on the Nomad servers and allow you to handle these sorts of secrets safely. Secrets can be managed via Nomad's web UI, CLI, or HTTP API. Jobs can render those secrets into templates or environment variables. In this example, the DB secret is being rendered into a TOML configuration file from the Nomad secure variable path key/billing. All of this is directly in your job specifications and can be configured from there. You have a product. You have service discovery, you have ingress, you have secrets, and now you have users. Everything is going great. It's time to scale not just your infrastructure, but your entire company. More servers, more employees, more users, more services, more of everything. And you're not alone anymore. You have employees and coworkers who need access to your Nomad cluster. While Nomad supports namespaces and fine-grained access control today, we are very excited to be simplifying user management in the near future. Single sign-on is coming in Nomad 1.4. Now, instead of having to manually generate and distribute tokens to each of your Nomad users, they can log in with your existing SSO providers. How do you scale service discovery? Nomad Service Discovery fulfilled your initial use cases, but as your company and cluster grows in size and complexity, Nomad Service Discovery may lack some of the features you need. HashiCorp Consul has a wide variety of networking services from fine-grained access control to a full service mesh. Consul can be seamlessly integrated with an existing Nomad cluster at any time. Now your apps have access to advanced networking features in Consul, such as the Consul Service Mesh, and fine-grained access and service controls. Migrating your apps from Nomad to Consul service discovery is as simple as switching the service provider in your job specification. Simply switching it from Nomad to Consul is all you need to do to now advertise this billing service in Consul instead of Nomad. How do we scale secrets management though? Because as your company grows, Nomad secure variables no longer meet all of your security and compliance needs. HashiCorp Vault not only manages secrets, but supports rotation and direct integration with all of your systems as well as your cloud provider. Vault can be integrated with a Nomad cluster at any time and used alongside Nomad secure variables. Migrating your apps from Nomad to Vault secrets is as simple as switching the template functions used to configure your apps. You can use secrets from both Nomad and Vault in the same configuration template to ease migration. What comes next? Congratulations, your company keeps growing and Nomad has features for even the largest enterprise organizations. No matter how large your company grows, HashiCorp Nomad is designed to grow with you. If you need to expand globally, Nomad has multi-region federation, allowing you to operate your global cluster from anywhere. Are your job specifications getting large and complex? Nomad Pack is similar to Helm and helps you simplify those complex app workflows. And do your teams fight over the same cluster resources? Quotas, a Nomad Enterprise feature, limits the resources any given app or team can use. Hopefully this helped you see how Nomad simplifies complex workflows and allows your ideas to scale from a home server to a global cluster. Please visit nomadproject.io and you can try Nomad for yourself. Thank you.